Hello, I am Brock Stanton. I am an aspiring meteorologist, and we are going to be talking mostly about this day 3 and day 4 enhanced risk. Both of these days have significant severe weather outbreak potential, which is why we'll be discussing them the most. We will also take a very brief look at this day 2 risk. It's not as significant of a risk, and normally I would spend more time covering it, but given the substantial outbreak potential for day 3 and day 4, it's just I need to try and keep the video not ridiculously long. And then there also is this day 1 slight risk. Won't really go over any more than this for the same exact reason as mentioned for the reason I won't be talking about day 2 as much. So that being said, we're going to start out taking a brief look at day 2 on the HRRR. And this is really the only reason I even want to bother talking about it this much. So we're going to get into Monday evening here. And this is the most aggressive with storm coverage, by the way. You can see these initial supercells start to develop. You can see we get several. This could grow more upscale than maybe the HRRR shows. Those are all supercell storms, but you can see this coverage of supercells and lines with perhaps embedded supercells capable of damaging winds and tornadoes. I'm going to take a sounding. On here you can see the looping photograph. There's also a pretty strong capping inversion right there at the low levels, so that is definitely something to watch for this risk, and that's likely why other storms don't fire nearly as much, if any storms. We'll just look at it a little more. Again, you can still see that looping photograph, a little less of a capping inversion there, but still definitely there. And again, I think that's why storms are not showing nearly as much with storm coverage. And even here, it says particularly dangerous situation tornado because there's no cap in that sounding. This is a pretty good sounding for a tornado. We're going to just take a quick look at the 850 jet and see how much low level shear there actually is for this, because that's pretty substantial. I mean, it really stays general. I don't think there's really going to be that much of a strong tornado potential with this setup, even with the more aggressive HRRR solution. So I think that might be quite aggressive by the HRRR. And now we're going to take a look at the NAM 3K, and we're just going to see no storms. There's a slight risk out, so I do think we can see at least a couple storms, but again, this casts a huge amount of doubt into the storm coverage. And we're just going to take a quick look at these couple more miles and just see how they only fire maybe like a couple storms down in this area. Again, not nearly as substantial in storm coverage as the HRRR. Again, looping photograph, some severe weather potential for sure. Just going to take a look at one more and then we're going to move on because we have a lot more substantial events to cover. Again, a couple storms, some of which could be severe. And again, if the capping inversion is not significant, we could see a tornado threat with these storms, because the low level shear is favorable for such severe weather threat. So now we're going to talk about our day 3 risk, and we're going to take a look at our NAM 3K. This can show us through 0Z. Just a reminder for what this area is. It's a very broad enhanced risk, ranging from Dallas, Texas, up into southern Iowa, including a large portion of central and eastern Oklahoma, into eastern Kansas and parts of western Missouri. So this is a very significant area, and we can see there is potential for significant severe weather. And based off the environment in place, as well as the Storm Prediction Center's wording in their outlook, this is probably for strong tornadoes being possible, as well as very large hail, which is again over 2 inches in diameter. So let's take a look, and we're going to just show you the uncertainty, and we'll show you why. So we're going to get into the day on Tuesday, the afternoon hours, and we're going to see the NAM, this is through 7 o'clock in the evening time, just doesn't fire a storm. Again, yesterday we talked about how there's a capping inversion that could suppress storm development, and it likely is going to do so to some extent, though we don't really know how much. So right now the risk is very uncertain, but the parameters I'm going to show you is why I'm very concerned about if storms do form, and some models do show storms forming, so we can definitely not just write this risk off. I think we can take a closer look in on central US here. We can see how we get into the day on Tuesday. Instability rapidly spreads northward, and these are going to be some right along the dry line. I think there's going to be where storms are going to initiate, where the most likely initiation will be. There's going to be strong instability. I mean, over 3,000, perhaps over 4,000 Cape, and that is going to be very favorable for supercell, for rapid supercell development. So let's just check a sounding here. You can see there's a little bit of a capping inversion. We can see it right there. Again, that's putting this uncertainty with storm coverage, because while we can see the frontal boundary dry line, we can see it right here. The larger scale lift is relatively weak, so combining that with the capping inversion does lead to uncertainty with storm coverage. You can see very, very robust Cape access. We're now going to take a look at our oil level jet. This is another thing that has me very concerned about the setup. And we can see, we get into 21Z, you can see fairly robust oil level jet, not the strongest, but as we get later into the evening hours, especially by 0Z, just take a look at a sounding here in central Oklahoma, see what we have. We have very weak cap. I would likely, the NAM doesn't fire storms with such a weak cap right next to a frontal boundary. It wouldn't surprise me if storms did initiate in a sounding like this. And let's just look at the thermodynamic environment. Surface-based Cape, over 4,000. Mixed layer Cape, over 4,000. It's a very favorable environment for significant severe weather, given the strong low-level shear with that sounding of, I believe, was like 40-45 knots at the 850 level. With I would argue in that particular sounding as extreme instability, even if the bulk shear, which I'm going to show you right now, isn't the greatest for tornadoes and supercell thunderstorms. I think the supercell, it's not, in this run, it's like 40 to 50 knots. That is actually favorable for supercell development, but not what you would suspect with the potential for a higher end event. Again, the thermodynamic environment is extremely favorable for supercells if storms can break through that cap, which is why I'm very concerned about this setup. We're now looking at our energy helicity index, which is a blend of shear and instability, and we're just going to see these values are going to explode right along the dry line. Here we get later, look, dry line's right here, just east it with that strong to extreme Cape right along the dry line. And again, we're going to take a sounding up here. Atmosphere is probably going to be capped. Yeah, that's a much more significant capping inversion, and that's why, despite the looping hodograph, despite the strong values for Cape, that's why it's plausible hazard is none, because storms would really, really struggle to break through that. Now let's just go a little farther down here. Again, I'm just checking for a capping inversion, because that's the biggest thing. Like, if this setup does not end out to be a severe weather outbreak, that's the reason why, and we really want to hope for that, but basically everything else is supportive for a severe weather outbreak, and tornado outbreak at that. So you just gotta basically just watch the capping inversion, and tomorrow all the high-res models will be in, so when I'm making a video then, hopefully we'll have a clearer idea. Again, I'm just checking for a capping inversion. That's basically what I'm doing. Not really too much of a cap in this sounding, but the best level shear hasn't arrived yet that far south. Let's check farther north, where we can remember the level shear was stronger and much stronger of a cap. Let's just check same area a little later. Still very much so there. Starting to weaken a little bit there, but that could definitely still inhibit thunderstorm development. And we'll just check here. Sorry for checking so many soundings. It's just, I find looking at soundings the best way to see if there's a capping inversion. Again, there's a weak cap there. And that just has so much uncertainty because the background environment is very favorable for tornadoes and very large hail, but just storm coverage is a huge uncertainty. And now we're looking at lapse rate, which is something I look for hail and supercell in more discrete supercell mode. And we can see we got values east of the dry line, 8, 8.5. I generally look for over 7 for a widespread severe weather event to be more favorable for discrete supercells. We have that in combination with the capping inversion, that if the capping inversion were to play out in a way more favorably for thunderstorm initiation, it's still going to be there somewhat, so that's still going to limit storm coverage to some extent, but that also means the storms that do form will be isolated. So it's a really tricky balance to try and figure out. But again, storms that do form, all the thermodynamics and the low level shear favor strong tornadoes. So that's really something we just have to watch. To go look at our CAPE. Let's look at our storm relative helicity values now. And we can see they're not too much. This is getting around 4 o'clock Central Time. We get into the evening, and they're going to, again, just east of that dry line is where they're going to be favorable for tornadoes. But, again, there's just a capping inversion, so that's going to put a lot of uncertainty into that storm coverage. That's really the big issue with this event. We're going to look at that 0 to 3 level. And we can see how that's definitely very sufficient for tornadoes. We're now just going to take a brief look at the regular NAM just so we can just see a couple hours further. That's really the only reason we're doing this. You can see, just look into the overnight, the NAM continues to increase those values along the dry line, but again, the fact that these values stay so high suggests to me that at least the NAM doesn't initiate it overnight, because if so, there would be less CAPE because storms have eaten up that instability. We can just see how it moves eastward the next day, and that's going to be our likely severe weather outbreak the next day. I am going to look at this model here. It's not my favorite model, but the reason I want to show you this is that it does convect the dry line during the day on Tuesday. Here we can go and see around peak heating, storms explode, semi-discrete. You can see this whole area in here has tornado potential. But the other thing is that storms initiate here. So let's see, 21Z, this is where the storms are. Let's look at the bulk shear. It's hour 57. It hasn't really arrived yet. And then the storms, let's see where the storms are on by 0Z. This is our area of bulk shear. By hour 60, they might be just a little bit off to the east of that, along or just maybe off to the east of that. So there, maybe the storms just initiate just a little too early before the greatest shear can arrive. So on the NAM, it didn't initiate storms whatsoever. On the, I believe we're on the FV3, HRF FV3, it just kind of, storms initiate perhaps a bit too early, or the bulk shear arrives a little too late. So it just goes to show the uncertainty with when storms will erupt. We're also going to take a look at the Euro for this. We'll just take a look. We haven't on the 12Z out yet. It's Tuesday. We can see how this robust instability axis develops. And here we can see it probably looks like storms do fire on this, just the way the instability develops. Let's look. 7. Yeah, so we can see by 21Z peak heating, storms do fire here, and then by 0Z Yeah, you can see storms are ongoing. So it's a lot of uncertainty with how storms are going to evolve. And that's the thing, that it's in very favorable environment is going to be primed for severe weather, but we just don't know how these very small scale features are going to pan out, and unfortunately might just be the whole type of event that's going to be very hard to see what's happening as it's happening, because we know the environment's going to be favorable for tornadoes, but it could be a day where we don't really know how many storms are going to initiate until either they're initiating or they're not. So it's kind of really difficult forecast for that. Let's look at the bulk shear. You can see by 21Z, remember the storms are firing down here in Oklahoma, there's just not the bulk shear to really support supercell development. Maybe that's area farther north in Kansas, maybe, but yet it's not there. It doesn't arrive till around 0Z. And then let's take a quick look at our 850 jet for the same exact reason. Again, it might not be there across southern Oklahoma until like 0Z, but maybe northern Oklahoma and Kansas, even at around peak heating. If storms do develop at peak heating, then perhaps those storms could develop more supercellular and be capable of all hazards much sooner than areas farther south. We're just going to take a real quick look at the GFS. You can see maybe a bit stronger of a level jet. Let's just check and see if the GFS decides it wants to initiate storms for this event or no. I'm trying to finish up talking about this day quickly because we still have a lot to break down with the other day. And GFS, again, doesn't initiate, but we'll just take a look at the EHI, which is a blend of things. And again, you're just going to see very strong values. And again, that just shows, again, I know I talk about how this parameter isn't perfect, but if you have values of like 8, 9, 10, 12, you know if a storm forms in that environment, it's going to be very favorable for severe weather because the values are just so high. Yeah, so that's Tuesday, and now we're going to move on to Wednesday, and this day also has pretty big outbreak potential. There's still a good bit of uncertainty with that, but there's a lot more confidence than what there was yesterday. Still not too high of confidence, but we can see this is a huge area highlighted for severe weather. Like, I mean, anywhere from New Orleans up through Chicago. That's absolutely massive. We're going to be looking at the NAM, and that's Tuesday, and as we get into the day on Wednesday, we can see how even early on in the morning hours, this is before sunrise, environment could be favorable for damaging winds and tornadoes, capping inversion there, so might struggle with the tornado threat. But as we move in, the cap will erode. This is only 7 in the morning. So you can see environment favorable of all hazards possible, including tornadoes. You can just see how you can see these little holes in the instability. That's a renegade storm development happened. When I say renegade, I mean ahead of the main round of thunderstorms, or in this case ahead of the cold front. Really just storms that fire out ahead of the frontal mechanism forcing, like smaller scale forcing out in the open warm sector. And we can see how this still into 7 o'clock in the evening, 7, 8 o'clock, we can still see how there's an environment thermodynamics that's still favorable for all hazards. And we're going to take a look at our upper level atmosphere now. You can see how in the morning hours there's this 50 to 60 knot low level jet already. So even though the NAM is depicting a 1-year storm mode in the morning, that line, if it happens as the way the NAM is projecting right now would still be favorable of all hazards, especially damaging winds and tornadoes just because of the storm mode. But even the lapse rates are favorable, so you could still get hail. And we're going to see, as we get into the afternoon, there's going to be the NAM depicts renegade supercell development in the warm sector. Again, 50 to 60 knot low level jet. Weakens a little bit in the evening, but we can still see into the evening 40, 50, 55 knot low level jet across this southern mode. And up here, still a 60 knot low level jet. This is a very concerning setup the NAM is depicting, because we have this strong level jet overspreading this huge warm sector. So this would be a huge amount of severe weather ongoing at the same time. I'm just going to use the EHI so it's easier to just visualize it. And again, this is like, see, now that's about 4 in the morning. There's this favorable environment up here for severe weather. But especially by 12, I know the values go down a little bit, but this is also the capping inversion, so threat will just continue to increase. And look at these values as we get into the afternoon hours, and you see how they continue to be favorable all the way up into Chicago. Let's take a sounding up there. See what we got. There's a sounding favorable for tornadoes. I don't know about the particular PDS. That's mostly probably driven by the strong low-level shear, but there's a tiny bit of veering of winds. And a lot of times with these like huge warm sector events, sometimes the storm mode is more linear up north, and you don't get as much supercell development ahead of the line. I can find that happening sometimes, so I don't know about strong tornadoes, but I mean with a 50 to 60 knot low level jet, even with the linear storm mode, you can absolutely get strong tornadoes. So again, we're just going to go. And this is kind of has me concerned about renegade supercell development right here, is the lapse rates. A lot of times farther east like this setup is, you don't see good lapse rates, and I consider good lapse rates for supercell development above 7. And we can see, and above 7 is just in the yellow, can see we're going to have those values above 7 across this entire event here. So that supports the potential for renegade supercell development if we can get any areas of any like small scale boundaries initiating storms in the open warm sector, which does appear to at least be possible with this event, possible if not likely. And see our bulk shear racing in. You can see this very strongly sheared environment. You can see this storms are, I believe, in this area right now, and then we move in. Again, this is a strongly deep layered and low level shear environment overlapping at least moderate instability. So the NAM depicts an all-day severe weather and tornado outbreak. This is the most aggressive solution, but also at this range, I trust the NAM over the GFS and Euro, so it's certainly concerning, even though it is the most aggressive, that this is the model that is showing it. We're going to look at our SRH values. You can see how they're already favorable, above 200, for strong tornadoes throughout the entire warm sector. You can see maybe they weaken a little bit as this low level, as the low level jet just weakens just a little bit, and then it'll ramp back up into the overnight hours. But really, this entire area in here has potential for a widespread severe weather outbreak. Certainly a very concerning setup. I know I've been mentioning about storms initiating in the open warm sector. I'm going to try and show that to you now. Oop. And again, this is this line of storms that's going to be ongoing along the cold front. See, there's our cold front. That's not our cold front, but cold front's probably just behind it. There's our showers and thunderstorms. It's already in a strongly sheared environment. You can see here in the late morning hours, perhaps trying to pick up on some renegade initiation. You can definitely see it here, because here's our frontal boundary would probably go down like this, and just a little bit out ahead of it. You can see this in It's renegade supercell development. Again, our frontal boundary is going down like this. So all this development here is renegade supercell development. Just in the NAM, it's depicting a more isolated mode. And again, so I mentioned this before, the NAM has a bias towards a more linear mode. So the fact that it's trying to initiate these isolated storms is very concerning for me across this area here. And again, we can see how it's going to continue. This is now 7 o'clock. This is as far out as this model goes. Though based off this solution, the severe threat would continue after this time. It's a very concerning solution the NAM has for Wednesday. You can see there's not a capping inversion, sufficient cape, strong shear. So we're going to have to look. Now, like I said, this is the most concerning model run. So we're now going to take a look at the GFS. And we're going to see that it's not going to develop the instability as much. You can see the GFS does have a tendency to underdo cape, underdo surface temperatures, and as such, underdo cape. So like I said, and that's why once the NAM comes into range, I tend to trust the NAM more. But we can still see how it develops this cape. See how it didn't really develop that morning mode though. So there's a little bit of uncertainty with exactly the timing for this outbreak to begin. Just see even up here when there's not much cape. Still an environment that's to do somewhat favorable for severe weather just because the shear is so strong with this system. Oh wow, it's not look 300 hours out. We're going to check out further down here in a blob of moderate instability. And the photograph isn't turning quite as much. And that's because I believe the GFS also has a little bit of a weaker, still pretty strong, but a little bit of a weaker 850 jet. Again, we can see here this axis of strong instability. A little bit of a turning, but not that large of a photograph. More southwesterly surface ones, but still a strong thermodynamic environment. And so definitely still severe weather would be likely with this. Let's take a look at that 850 jet. See, this is 12Z. You can still see, still very powerful. This is 7 in the morning. So you can still see if that line of storms were to develop with sufficient instability, still would definitely be capable of all hazards. You can see it weakens a little more around 4 o'clock, like 4 o'clock in the afternoon. But still, a 40 knot low level jet still would support all hazards. And it doesn't ramp it up as much across the southern mode back into 0Z. So that's definitely good news. But again, this is still a broad 850 jet overspreading a warm sector. That's never good news and is almost always going to lead to a significant severe weather event, especially when the instability values are getting over 1,000, which, even though then GFS is less aggressive, you can still see here's our quarter of 1,000 plus instability. So, I mean, all that would still support a severe weather outbreak, I would think. You can see the bulk shear does not advance as rapidly, but still, I mean, this area 30 to 40, maybe 45 knots of bulk shear ahead of this. Still going to support a tornado threat, especially when, remember, in this area there was a strong instability access. So again, still a severe weather outbreak would seem likely, despite the not as strong shear. You can see storm relative helicity values are not going to be as strong because of that not as robust low level jet. But still, values over 150 do favor a tornado threat, and 200, again, this is barring other ingredient strong tornadoes, so it's not as if the tornado threat is low with this, it's just not quite as high as what the NAM is depicting. Still very concerned about a severe weather outbreak based off this run of the GFS, and this has also shown a more significant severe weather threat than what the GFS was showing yesterday, so it's also important to watch the trends and realize that it's trending towards a more significant outbreak of storms. And we're now going to take a look at the Euro. Let's just see how far still show us 300. Let's look at 60 then. Take a look at the Cape. And we're going to see that it has this instability possible if that morning mode does develop. You can still see this axis of moderate instability, again spreading all the way up, like probably into the Chicago area. Moderate instability. So this is still very significant for severe weather. Again, this moderate instability axis spreading so far north is still a very concerning setup for severe weather. We're just going to take a look at, let's see, our bulk shear. We're going to see how that overspreads the warm sector. And this does it much similarly to the NAM of a 50, 60 knots, maybe even 60 to 70 knots, depending on exactly where you are overspreading the warm sector in these westerly or west-southwesterly winds aloft. See how that turns? Very little veering, a little bit right there, but overall pretty clean sounding that supports that tornado threat. So Euro seems to be winding up somewhat more with the NAM so far, at least shear-wise. Now let's take a look at the 850 jet. Look how it's that 50 to 60 knots in the morning, and this again seems to be leaning a little more towards the NAM solution, which is definitely concerning. 15 late morning hours into the afternoon. You can see how it still maintains on the Euro that 50 to 60 knot low level jet, at its peak, and still widespread over 40 knots into peak heating. Oop, switched to the wrong hour there. And intensifies it more into the overnight hours. This is as we start getting into the overnight hours, this is a very significant, it's very likely going to be a severe weather and tornado outbreak day 4. This is such a broad area where there's going to be strong low-level shear overspreading moderate instability that you just know when there's storms in that environment you're going to have a lot of issues with severe weather. Just take a look and see our storms here. You can see here's probably our cold front. This is likely the prefrontal bit into storms. The Euro tries to develop it into more of a squall line, which would still be a dangerous severe weather event, but certainly it's better to have a squall line than discrete supercells considering the low-level shear we're dealing with. But again, that it doesn't like this means we're not going to be dealing with a severe weather and tornado threat just because the storm mode on the Euro, which, by the way, medium range models do a crappy job at depicting storm mode, and the lapse rates are still favorable for supercells. The bulk shear is favorable for supercells, so that tends to make me think that we'll still be dealing with at least some supercell storms possible in the open and warm sector. And again, this entire day 4 area, watch out for it, could be quite substantial for severe weather outbreak. This is definitely the day that I have the most concern about right now. I mean, it's not like Tuesday, it's not, again, I've said this for Tuesday, if that capping inversion does break, you could have supercells developing capable of all hazards, but on day 4, there's higher confidence that we're going to be seeing those storms in the warm sector, and it's such a large area at risk. Again, all the way down from the Gulf Coast, New Orleans, up into southeastern Minnesota. That's an extremely large area for severe weather. Again, all hazards will be possible with this, so I'm going to wrap up the video. If you enjoyed it, please like and consider subscribing, but I'm definitely going to have to make sure, even with school tomorrow, that I'm getting a video out on this, because this is Tuesday and Wednesday have potential to be very substantial for severe weather outbreaks, but I will see you next time. Bye.